Hey everybody, welcome to Lab 6, the axial skeleton as opposed to the appendicular skeleton. So, do we have two skeletons in our body? No, but we can divide our skeleton into the main axis, which is the skull and this rib cage and the spinal cord, or not spinal cord, the vertebral column, which protects the spinal cord, and then also the appendicular skeleton, which is anything that hangs off of that axis, okay? So, normally in the lab, I'd be showing you human skeletons to be able to, and we don't have any real live human skeletons in this lab. We have plastic. Turns out it's hard to get human remains. Go figure. But I don't have any plastic human models at home, but what I do have are actual animal skeletons because I'm a comparative physiologist, which means I look at how other animals compare to us. And I also am from Texas, and so people just always give me their skulls. Parents of students would say, "Oh, look, I found this. Do you want this?" And I'd be like, "Yeah, okay, I can use that in class." This is a bighorn sheep, so it looks like a scary goat, but it's actually a bighorn sheep. Okay, and that's all that matters right now. So we can actually use this to compare to the human skeleton because it has all the same parts as a human skeleton, just except it's got some extra parts like these guys, clearly, and its parts are arranged in different ways. Okay, so if you are looking at a skull, you will notice one of the first things you notice is all these little they're called sutures. They look like little stitched parts. Okay, and these are really important. Like, look at that stitch part. Look at the ones back there. These are important because when a mammal is born, its skull is not fully fused, often, especially in humans. If our skull were fully fused, it would not be able to fit out of the birth canal. That's one of our brains are just so big and our heads are so big to hold that brain that there's no way that the skull could be fully fused and get out of a human being. Okay, so you see all these sutures, which are where the skull, these are called fontanelles in a baby. And if you've ever had a baby or held a baby, they tell you be really careful of the soft spots on a brain, or on the skull, the baby's skull, because that's where the brain has not fully formed yet. So those will eventually end up suturing together or fusing together, and then you end up with a full skull. Now, this actually still isn't just one bone. This is many, many bones put together. So whenever you look at a skull, you're going to see sutures, which I just talked about. That's where things fuse together. You're going to see holes. Okay, not just the orbit, which is where the eyeball is, but all these other holes. Look, there's a hole in there. There's many holes in there. You're going to see, ooh, that's going to be important. You're going to see places where different parts of this skull come together. Okay, boop. Let's see. There we go. So do you see this arch? This is the cheekbone. Okay. Well, technically, we call it the cheekbone when we're not doing anatomy. When we're doing anatomy, it's called the zygomatic arch. Now, the zygomatic arch is made of the temporal bone, which is the bone back here, and the zygomatic bone, which is the bone up here. So you have two different parts to this arch. Now, here's where anatomy gets annoying when you're talking about labels. So we will call this arch that comes off the zygomatic, and this is found in humans also, it's called the temporal what is it called? The temporal process of the zygomatic arch. So it's the process. Whenever we say process in anatomy, we mean sticky outy bit, the part that sticks out. Okay, so the temporal process of the zygomatic arch is the sticky outy bit that touches the temporal bone of the zygomatic arch. Okay, but the zygomatic process of the temporal bone is the one that comes off of the temporal bone and touches the zygomatic. Oh no, there's so much to learn. I know. But that's okay because you have a cool list in your lab. Okay, we're going to get back to the good old, I need to name that skull or something, that skull soon. But in your lab, you're going to see, I really want to hit this hard because I feel like the question set only sort of goes over it and it doesn't really hit the importance of what you need to know for this lab. This figure is strange. So you need to make sure, again, you are looking at all of the things that are bulleted and bolded. Okay, so I'm not really as concerned about these two right now, the spongy versus compact bone, as I am the fontanelles. Okay, so whenever you look at a fetal skull, you're going to see fontanelles, which are the places where those sutures come together. I don't care if you know which suture is what. You might need to know it for some of the lab questions, but you don't for the practical. But you'll see that there are different parts of the skull that you'll need to label, and you'll need to know exactly where they are. So you can practice on yourself. So the temporal bones are where your ears are. Okay, so your temporal bone is there. Your sphenoid is inside, so it's kind of up in there. Your ethmoid is also in there. Your frontal bone, guess where that is? In the front. Okay, the parietal and occipital are in the back of the skull. You're going to go through this and you're, oh no, look at all these things. Oh, the front, here's the things I just talked about, the frontal, the parietal, the temporal bones, but you have to learn certain features on them. Okay, so sutures are where things come together. Sinuses are just holes. If you've ever had a sinus infection, you totally know about that. Okay, so there are these, whenever we breathe in, the air that comes in has to be warmed up and moisturized, which sounds weird, but it basically has to be moistened, that's the word I'm looking for, before it gets to the lungs, or else it'll hurt the lungs. So we have these cavities in our brain which allow air to warm up over time. It also, if we didn't have those sinuses in our brains, our skulls would be way too heavy. Our necks would have to go like this completely just so we could hold up our skull. So the sinuses also allow our skulls to be a bit less heavy. Okay, as you go through this is where you're really going to rely on your book, because you're going to be looking for every single one of these things on a skull. Here's where I talked about the zygomatic bone has a temporal process. The temporal bone has a zygomatic process, and they fuse to make the zygomatic arch, or your cheekbone. Okay, so, so many things, I know, but it's so important. Once you get these in your head, they won't leave your head ever. It's fantastic. Okay, so these are our cranial bones. They're the ones that make up the big bulby part of our skull, the face, and then all the different the parts of them that you need to know. Make sure you know each one of these. If I point to it on a skull, if I go, hey, what's this thing called? You'll be able to tell me. Okay, then that's some practice for you. Okay, then the facial bones are all the bones that make up our face. What a fun coincidence. Okay, your lacrimal, that's going to be where your lacrimal is the bone inside the orbit. So the orbit is made of several different bones, the orbit being where your eye is. Okay, if you look at it on our goat friend, you can see there's a lot of different, there we go. There's a lot of sutures that put it together. So the lacrimal is going to be right here. I don't know if sheep cry. I don't think they do, but if they did, that's called the lacrimal. Okay, then we go around it and we see other different parts. You'll see there are lots of holes in there. Those holes are called foramen, and that's where nerves come out. Okay, so that's not where your tears are flowing. That's something else. That's where your nerves come out from your brain to attach to the different parts of your face, because our face is one of our most heavily innervated or nervous connected parts of the body, because we have to be able to control all the muscles so carefully so we can express ourselves to each other. Oh, express. Okay, the mandible. So this is the mandible of our goat friends. The mandible is the jaw, okay? Now, you may have been to the dentist and they tell you, bite down on this. Guys, we don't bite down. We bite up. The way that we bite is that we close our jaw and our mandible goes up. It's just a weird language thing that we never say, bite up, right? Because that sounds weird. But think about it. Try it. Tell your friends. Tell them, guess what? You don't bite down. You bite up. It'll blow their minds. It's fantastic, okay? Also, so you may have noticed these guys hanging out over here. I took a puppet class once, and one of the biggest things that they tell us is that when you're doing a puppet, people want to just open up blah, 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 like that. But that's not how our bodies work. Our bodies work by the bottom jaw opening up and down, and that's really hard. But again, it's that idea of our mandible opens up and down, not the whole, our head doesn't flop around, okay? All right, so you're going to learn these things. I don't actually care about activity 5. This is just to help you if you want to memorize these things. I'm going to give you a list of a lot of these. Oh, my dog is hiding under my feet. I don't know what's happening there. I'm not giving you a list. Sorry. You need to be able to know these things without a list for your practical. Now, what I would do is as you're going through this, you are adding all of these bolded things to a list. So by the end of this, you're going to have a list of all the bones and features you need. There are 206 bones in the body, but if you include the features, it's so many more. We're not doing all of them. You're only responsible for the ones on our list, okay? So that's the skull. The skull is complicated enough, right? Oh boy, okay? My dog is, I think there's fireworks outside. It's freaking out my dog. Okay. Now, let's talk about the hyoid. If you are a fan of true crime, if you have ever watched an episode of SVU or the show Bones, they talk about if someone's been strangled, you can tell because the hyoid gets cracked. So the hyoid bone is a bone that's floating in our neck, and it's what attaches to our tongue. So if you put your hand kind of here, you can feel something moving around. That thing moving around is actually the base of your tongue, and it's attached to the hyoid bone. We can tell in ancestral human species like Neanderthals and other things that we can tell exactly when language might have evolved, because some of them don't have a hyoid bone, so they can't have had language. Okay, or at least not the kind of language that we have with tongues. Okay, interesting. Then we continue down the axial skeleton. You get into the vertebral column. What I need you to know for this are how to identify the three different parts of the cervical of the vertebra. So we have the cervical, the ones around the neck, the thoracic, the ones in the thorax, which is a weird thing to think about in humans, but it is your trunk. Okay, so, and then you have your lumbar. Your lumbar are the biggest because guess what? The human spine is stupid. It was not evolved originally to stand upright. So we had to evolve these really big, heavy lumbar vertebra because they have to hold everything else up. And if they don't, the whole thing crumbles. It's like a really bad game of Jenga. Okay, so the lumbar vertebra have to be extra big to support all of these all these bones. Cool. And all the muscles on top of it and our big old heads and everything. Okay, so that's why if you get lower back pain, you're feeling it in your lumbar vertebra because these are already as big as they can be, and they start to crush the vertebral discs in between them, and then you can get like sciatica and stuff like that. It's fantastic. When you're looking at these different kinds of, when you're looking at these different types of vertebra, you're going to also have to know what the atlas and axis are. They're the reasons that we can move our head in so many directions. So the atlas is the one that sits right underneath the skull. So it's the very first cervical vertebra, and it holds our skull like this and allows us to go up and down. Okay, and you can tell because it's very, very flat, so our skull can ride up and down on top of it. You know what I forgot to talk about? When you get into the temporal bone, not the temporal, like the occipital and the parietal and those guys, you are going to be looking at the bottom of the skull. Okay, a lot of stuff is going on the bottom of the skull. You don't have to know all of it, but you do have to know the foramen magnum, or the magnum foramen, which is the giant foramen, the giant hole. That's where your spine comes out. The atlas sits right underneath this, and that allows the skull to go up and down. There's another thing called the axis, the next one, which has a little thing called the dens, which means tooth, and it sticks up and it allows the skull to go to it allows you to shake your head, it allows you to go back and forth. Okay, interesting. Use your book to find all these different parts. I don't think this lab. Oh, and then the lab questions will also have you go through everything. Everything you need. You're going to then make sure you know how to tell the difference between and I added a whole bunch of extra pictures at the end of this to help you practice, because I think the best thing you can do is just keep looking at more and more pictures and figuring it out. You'll notice there are way more labeled things on here than we need to know, and that is because I don't care. Because like there are so many extra things on here, there's only some things you need to know. You need to know this styloid process. You need to know these occipital processes. Okay, you need to know the sphenoid, you need to know the palate. Just make sure you're using your list to look at these. You're not necessarily going to use all the labels. I just wanted you to have the best pictures possible. Okay, so let's look. How can I tell that this is the dens or the axis, which is one of the cervical vertebra? So all cervical vertebra have these holes, these foramen. You'll notice this is a cervical vertebra, this is a thoracic vertebra, this is a lumbar vertebra. Why do they have these? Because they're holding the nerves that are coming out of our brain before they get to the rest of the body. Okay, so very, very important. Your cervical vertebra have these holes. Okay, if they have those holes and then some specialization, so there's a hole there. Ooh, it's kind of weird on this one. They're kind of off to the side there. Then we're talking about the atlas and the axis. Okay. This is the atlas. This is the atlas because it's very flat, but it still has those foramen. This is the axis because it allows us to turn on an axis, and that axis is the dens, which is the sticky outy bit here. That is not to be confused with, some people sometimes confuse this bone with the human mandible, because unlike in goats where it's just one piece and stuck in the middle, our mandible forms a line, right? It's one complete piece. Note that there are no teeth in this though. There are some processes that stick out, but there are no places for teeth, which means this can't be the mandible. This has to be the hyoid bone. So the hyoid bone looks kind of like fake vampire teeth, if you've ever had those, but like really bad fake vampire teeth. Okay? Okay, so cervical vertebra. I know this is a thoracic vertebra because it has these, it's starting to develop these winged processes out to the side and this single spine here off the edge. And it's got these extra kind of cushion places for the ribs to attach. Interesting. So these are where they attach to each other in a line. This is where they attach to the next one, also in a line. These are where the ribs attach, okay? You'll notice you don't see, if this is the body of the vertebra, you don't see that in the cervical, you don't see that in the lumbar. And how do I know my lumbar? Because they're gigantic. They have a gigantic body. They don't have the foramen, and they also don't have that extra spot for the ribs to attach or articulate. Whenever we have bones that are together, whenever bones stick together, that's called articulation. Okay, if you have a disarticulated skeleton, that means it's been taken apart. All right, let's look at the ribs. Oh, ribs. The rib cage. It looks so simple, doesn't it? Oh. So the very first part of the rib cage is actually the clavicle. Okay, that's usually what breaks if you fall on your face and you put your arms out, but it's actually better to break the clavicle than it is to break the rib cage. And also when you break a rib, you can't get splinted. So when you break like an arm, they splint it so you can't move it so the bones can stick together. But you can't do that with the rib cage because the rib cage has this cartilage in between the sternum and the ribs that allows it to get bigger and smaller as the lungs inflate and deflate. So you can't splint the thoracic area because then you wouldn't be able to breathe, okay? You'll notice we have what are called true ribs. They're the ones that attach one-on-one with the sternum, which is the central piece, okay? So the true rib, true rib, true rib, true rib. Oh, what is this? These are the false ribs. False ribs, I believe that's what they're called. And then we have floating ribs. So the ones that all attach to one thing, those are your false ribs. I believe that's what they're called. Okay, the sternum in the middle, okay, that's if you've ever learned CPR, that's where you learned that this is the sternum. It has this process, the sticky outy bit at the end called the xiphoid process. It has the manubrium, which is the top part, and it has the body, okay? So make sure you know all of those parts. How do I know that this is a sternum and not, say, the coccyx, which is part of the lumbar vertebra? Well, there's no holes, okay? So if you go and you look at the bottom of the vertebra, there's a good picture. Cool, cool, cool. Good stuff. Okay, so if you look at the bottom of the vertebra, there is what people might call it your butt bone. People might call it your tailbone. It's technically called the sacrum. So the sacrum is the very last part of the vertebral column. It's where all of these vertebrae have become fused together. You can tell that this is a sacrum, and I would look at pictures to look what else it looks like, because it's got these foramen in it, again, so that you can have nerves coming out of the spinal cord and then going to the legs. Okay, you can see it curves on the ear. This is the coccyx. Okay, so I can tell that this is a sacrum and not the sternum because it's got a curved shape and it's got these foramen. It also is wider, okay? In the other case, in this case with the sternum, I know this is the sternum because it has these ridges for where the ribs attach. It doesn't have foramen and it's very long instead of being wide. Okay, so there's a lot of things to practice in this. I suggest just practicing these over and over with as many labeled or unlabeled figures as you can, and check your work because that's the best thing to do with this. There's literally nothing else I can do except say, oh my God, good luck memorizing. You got this, okay? I believe in you. Let me know if you have questions.